Hey, Algebra 2, this is the first half of the Chapter 9 review that I'm going to go through with you. I encourage you to do these problems on your own if you can, but watch them through on this video and make sure that you know how to do them so that you can prepare yourself for the test that will be coming here in the next couple days. We're going to try to get through the first page and then we'll save the back page for tomorrow. And then we'll test after that. So this is only sections 1 through 3 for chapter 9. So 9:1 through 9:3. If you need to look back on those to see what you're doing, that's all that we're going to test over for chapter 9. And then after chapter 9, we'll start our end of the year review over little bits and pieces. So let's jump right into 1, 2, and 3. They're asking for the 6 trig functions, which I have listed here: sine, cosine, tangent, cosecant, secant, cotangent. If you remember from this section, like sine and cosecant go together, cosine and secant go together, and tangent and cotangent go together. That's like how they work. So the thing that we need though here is we need to label all the sides, and the angle that we're looking at is angle theta. Okay, we're not looking about, we never do anything in relationship to the 90-degree angle, but sometimes we'll pick on the other angle. This is not the angle that we're looking at. We're looking at angle theta. Okay, so we need to though find what this third side is right here, and we can do that by doing the Pythagorean theorem. So when we do that, we need a squared, b squared, c squared, and the thing to remember is that side c is always the long side, or the one that's opposite the 90-degree angle. So this has to be c, and then it doesn't matter which one is a or b from there. Okay, so let's just call the one that we don't know a. So a squared plus 5 squared equals 13 squared. Okay, then we just do the math from there. So a squared plus 25 equals 169. And if we subtract the 25 over, we get that a squared equals 144. And when you take the square root, that comes out perfectly as 12. Now, some of you might have known already that this was a 5, 12, 13 right triangle, because those are the three. It's called a Pythagorean triple, or it's a perfect right triangle where those come out without any decimals. So that's kind of how that works. All right, now let's see. I'm going to erase some of my bubbles here. A, B, C. Let's go to a different color here. We're looking at angle theta, and then we label our sides opposite, hypotenuse, adjacent. Okay, so the opposite side is going to be 5. So this is O. The hypotenuse side we said was 13, and the adjacent side, or the one right next to him, is 12. So that's how I label AOH. And then for my 6 trig functions, I go back to SOHCAHTOA, S-O-H, C-A-H, T-O-A, and they just want me to write out the fractions, I think. Find the values. Yep. So for sine, it'll be opposite goes on the top and hypotenuse goes last. So the opposite is 5, the hypotenuse is 13, so that's how that will work. Okay, cosecant is going to be the opposite of that, so 13 over 5. Okay, then cosine is adjacent over hypotenuse, here and here. So we've got 12 over 13. Okay, and then secant would be 13 over 12. And then tangent is opposite adjacent, so the opposite side is 5, the adjacent side is 12. And then this cotangent will be 12 over 5. So those fill in pretty quick after you have the triangle kind of established, and that should work from there. All right. Now, number 2, we're going to have a triangle that doesn't come out very nice. Here's our angle theta. That's what we're looking at. We're not looking here, and we're not looking here. We're only looking at that angle. So like we have 16 is the opposite. 12 is going to be the adjacent side, and this is the hypotenuse side, but we don't know what he is. So we've got to find him, and that's going to be my side C. So A we'll say is 12. 12 squared plus 16 squared equals C squared. Okay, 12 squared I know is 144. 16 squared is 256. And that's what C squared is. Now I got to do some math. Hold on. 144 and 256 is 3. No, that's 400, I think. 400 is C squared. Let me check that. Plus 256. 400, yep. And then when I take the square root, C equals the square root of 400, which is 20, I believe. 20. So this side is going to be 20 units. Now, The deal here is, don't get too far ahead of yourself. The deal here is that when we go and put these numbers down here as fractions, like something over something, I know that 12 and 16 and 20, I don't know if you realize this, can all be reduced. They all can be divisible by, what, 4? So if I do that and I divide by 4, I'm going to go ahead and divide by 4 up here and reduce them to begin with. That way I don't have to reduce them 6 times down here, right? If I were just reduce them 1 time. So this would be 3 if I divide by 4. This would be 4, and this would be 5. That is a 3, 4, 5 right triangle. So that one comes out perfectly too, okay? And then we just have to do our opposite, hypotenuse, adjacent, all that good stuff, okay? So sine, S-O-H-C-A-H. If you just want to write this at the top of your paper, you don't have to keep writing it down a bunch of times. Sine is opposite hypotenuse. So from angle theta, opposite is 4, hypotenuse is 5, so 4/5. Cosecant would be 5/4. Cosine is AH, so 3/4. No, 3/5. Hypotenuse is 5, so 3/5. And 5/3. And then tangent is OA, and O is 4, and A is 3. And then 3/4 would be cotangent. So there you go. All right, so reducing them up here will help to not have to reduce them down there. So that's just kind of a little tidbit. Number 3. All right, here's my angle. I know that 8 is the opposite, 17 is the hypotenuse, so this is the adjacent side, and we don't know what he is, so let's do a squared, b squared, c squared. I'm going to say A is the one that we don't know, B we'll call B 8, and then C has to be 17, because that's the hypotenuse, okay? So A squared plus 64 equals, I think that's 289. Let me check that, though. Yep. And then I have to subtract the 64 over this time. And A squared equals 225. If we take the square root, then A is 15. That one comes out nicely. So actually, all 3 of these triangles, 1, 2, 3, those are all perfect Pythagorean triangles, right? This one was a 5, 12, 13 was the first one. We had a 3, 4, 5. And then we had a 8, 15, 17 triangle. Now, we'll learn in geometry next year. We'll get used to dealing with these a lot. And the trick there is, if you have a triangle, you don't have to go through this process and this process and this process to find the Pythagorean theorem if you have these memorized, right? And it's not that hard to memorize them. So if you do that, then you can skip over the Pythagorean theorem and just fill those numbers in. There are also 2 more that I make my geometry kids learn, and they are a 7, 24, 25. Those ones come out perfectly in the Pythagorean theorem, and a 9, 40, 41. Those ones come out perfectly as right triangles, okay? You might see those down below later as well, but that's how that works. So if you know those, and there's more beyond that, like there's some that's like 101, 147, I don't even know. Like there's some that are in the hundreds, don't write that down. But like some of them, like there are a ton more Pythagorean triples, but they get to be such large numbers that it doesn't really matter. But those are the ones that if you can remember those, then you can kind of have a little bit of an advantage because you don't have to do the Pythagorean theorem every time. All right, there's my soapbox. All right, here we go. Let's do some sine, cosine, tangent, and secant, cosecant, cotangent. So SOH, I'm using all the colors, I guess, today. SOHCAHTOA. All right. OH, so we've already labeled this is O, this is A, this is H. All right, here we go. O is going to be 8, H is going to be 17, 8 and 17, and 17 and 8 for cosecant. AH is 15, 17, or 17, 15. And OA is 8, 15, and 15, 8. That's those fractions, how that boils down. So 1, 2, 3, there you go. Okay? All right, next. Number 4, it says, if tangent of some angle is 7/12, what is cosine? Okay, this gets a little bit confusing, but what we're going to do is we're going to draw a triangle. And I always just face him this direction because then I can slap angle theta down in the corner there. Okay, so I always put angle theta in the bottom right corner. You could technically make him go a different direction, but I just always make my triangle go that way. And then I know that tangent is the TOA part. So that means this guy, this 7 must be the opposite side, and the A must be 12, right? So the opposite side is 7, which is here, and the adjacent side, which is this guy, is 12, okay? Then we have to find out what this one is using the Pythagorean theorem, and then we can find cosine, okay? So let's do that. This is my side C because he's the hypotenuse. So let's do like 12 squared plus 7 squared equals C squared, okay? All right, I'll try to go a little bit faster. 144 is what 12 squared, 49 equals C squared. This is 193. Let me check that. And then we have to take the square root of 193. 49 is the square root. Yep. And then when we take the square root of 193 does not come out nicely. So what we're going to do is we're going to just leave it as the square root of 193. We're just going to write it like that, okay? And now we just have to find the cosine value. Okay, if this is my angle theta, then cosine would be adjacent over hypotenuse. So cosine of A will be equal to the adjacent, which is 12, the hypotenuse, which is 193. Now, I think when we did this section, we said, don't leave the square root in the bottom. I don't remember for sure. I think we said, yeah, get rid of the square root out of the bottom because this is technically considered to be improper. Improper. So what we do is to get rid of that square root out of the bottom, we multiply by the square root of 193 over the square root of 193 because I don't want that 193 in the bottom. Okay, and what happens here is when you multiply those together, that 193 comes out of the square root, but then when you multiply these together, this just becomes 12 square roots of 193. So we're making it look uglier technically, but it's now considered to be proper. It's kind of like when you have an improper fraction, like 7 over 5, like they want you to change that to be 1 2/5 as a mixed number. I think this actually looks uglier than this one, but that's considered to be proper now, right? So kind of like along those same lines, all right? So that's how that works. Number 5, cosine. We're going to draw a triangle again, and we have 1/2. So let's call our angle, I called it theta over here, but it actually wasn't named theta. It was actually named A, if you were confused. It's called angle A. That's just the variable. It doesn't really matter. Angle A, and then cosine is the CAH part. A is going to be 1, and H is going to be 2. Adjacent side is 1, hypotenuse side is 2, and so then we have to figure out what this guy is, okay? So let's do our Pythagorean theorem. This is side C. So we've got 1 squared plus, we'll call it B. B squared equals 2 squared. And this is 1 plus B squared equals 4. If I subtract 1, B squared equals 3, and then I take the square root, and the square root of 3 does not come out nicely, so we're just going to leave it as the square root of 3 and put it in that spot, okay? Then the last thing that we have to do is find tangent, okay? Tangent of A, and tangent is OA, opposite over adjacent, okay? So the opposite side is going to be the square root of 3, and the adjacent side is 1. Now you don't necessarily have to have that 1 on the bottom, so I could just call it the square root of 3 if I wanted to, and that's what he will look like, okay? All right, number 6. We've got our triangle here, and I've got, they call it angle B. Sine is SOH, so we have the opposite and the hypotenuse. Opposite side is 3, hypotenuse side is 8, okay? And then we have to find this third one. My side C is 8, so let's go 3 squared plus B squared equals 8 squared. Okay, 3 squared is 9, plus B squared equals 64, and if I subtract the 9 over, B squared equals 55. I can't, my brain just froze for a second. Okay, if we take the square root of 55 doesn't come out nice, so we'll just leave it as the square root of 55, and then we have to find tangent, okay? Tangent of B. Okay, is doing the opposite over the adjacent because it's TOA. Okay, the opposite side is 3. The adjacent side is the square root of 55, which is considered improper because we don't want the 55 on the bottom. So I'm going to multiply by 55 and 55. And that, if I multiply these two together, the 55 just pops out, no more square root anymore. And then I have 3 square roots of 55. That's how that works. And this is considered to be proper now, okay? So that was that. All right, those ones are the long ones. Those ones take forever. The rest of them don't take too long, I don't think. 7 through 12 have all the same instructions, and you're trying to find the value of x rounded to the nearest tenth. That's just one decimal place for each one of these, okay? One decimal place. So the deal here is on 7, 8, and 9, these three right here, you are solving for a side, like side x, side x, side x. But in the bottom three, you are solving for the angle, 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 okay? So you'll notice that we'll do something just slightly different when we're solving for the angle versus the side. Some of you probably already know it because we've done it before. And so let's jump right in. Let's do number 7, and then we'll check back and compare, okay? So the nice thing about when we're doing these is that you don't have to do all 6 of them, but you have to pick which one you're going to use, right? So we have SOHCAHTOA, SOHCAHTOA, okay, we've got that. And I'm going to decide which one of those 3 we're going to use based upon where the angle and the other 2 sides are. So I have 38 degrees, 10 is what I have labeled, he is the opposite side, and x is the adjacent side. So I want the one that uses opposite adjacent, which is tangent, okay? So I'm going to set up tangent, and inside of the tangent, I always put the angle, which is 38 degrees, and then I put opposite over adjacent, which is 10 over x, okay? So just similar to what we did up here, except now I have a value for each angle. I have 38 degrees goes in here, and then I do my fraction on the right side. So it's exactly the same thing as what we were doing before. It's just that now we actually have 38 degrees to work with, okay? Instead of just writing out the fraction, okay? Now, this one's a little tricky because when the x is on the bottom here, we've said before that you could just switch those two. So like x can come over here, and then 10 can go, or the tangent 38 can go on the bottom of the 10. And then all I have to do is type that into my calculator and get a value for x. Okay, all right, let's see what we've got. 10 divided by, and I got 12.8 if you round correctly. This one side was 10, so 12.8 sounds about reasonable. 38 degrees, yeah, that seems reasonable. So 12.8, I'm guessing that should be correct, okay? Number 8's the same way, so we've got 63 degrees. We've got to decide 4 is the adjacent side, and x is the hypotenuse side. So out of the SOHCAHTOA, I'm going to use cosine. All right, so we do cosine of 63 equals, and the a goes on top and the h goes on bottom, so 4 over x. And this is another one where we're just going to swap those, okay? So x goes here, 4 over cosine 63, and we get, as an answer, let me type it in here, 4 divided by, and I got 8.8. Okay, now 8.8, this was the hypotenuse, right? And 4 was one of my other sides. So I know that the hypotenuse has to be the biggest side. And, you know, 8.8, that sounds about right because, I mean, 4, it's obviously bigger than 4. So there you go. Number 9, same thing, 20 degrees. I've got x is the opposite side, and this one is the, ooh, looks like the adjacent side, but that's actually the hypotenuse. So out of the SOHCAHTOA, we're going to choose sine, and sine of 20 equals opposite, which is x, and the hypotenuse is 14.5. Now when the x is on the, or when the 14.5 is on the bottom and x is on the top, we can just get rid of the 14.5 by multiplying him to the other side, right? We don't have to flip the 2 around. So x, I can just plug this in, 14.5 times sine of 20, and it should give me an answer. And I got x equals, oh man, 4.95, but if I round up, that would actually be 5.0 is what that value would be, okay? So yeah, rounding to the nearest 1 degree or 1 decimal place, 5.0 is what he will be, okay? All right, these bottom 3. We're going to set them up the same. Here's my angle. I have the adjacent side here, and I have the hypotenuse side here. So we're going to use the CAH one, all right, which is cosine. And we still put the angle in here, even though we don't know it, right? And then what we do is we put A on top, which is 4, and H on bottom, which is 7. And then what I do to get the x out of here is I do the inverse cosine, because those cancel, and I do the inverse cosine of 4 over 7. So that's like in your calculator, you have that shift button. So I do shift cosine of 4 over 7, and it should spit out a value for me. So 4 over 7. And there we go. And this is, I'm getting 55.2 degrees is what I get, 55.2 degrees, okay? So on these, you're going to have to do that inverse cosine at the end, or inverse sine or inverse tangent, okay? And that's what he looks like. All right, moving on to number 11. I'm trying to go decently fast. We've got our adjacent side and our hypotenuse side, so that one is going to be cosine again, I think. It goes CAH. So cosine of x equals, the A goes on top, which is 13. The H goes on bottom, which is 33. So then we've got to do that inverse cosine. So inverse cosine, inverse cosine. We type that into the calculator, inverse cosine of 13 over 33. And I get 66.8 degrees. Okay, practice typing that in yourself to make sure that you get the same. I mean, I could be wrong too, so that's a thing. 12, x is there. We've got the opposite and we've got the hypotenuse, okay? So that's going to be sine, or SOH. We've got sine of x equals, the opposite is 4, the hypotenuse is 10. And then we have to do the inverse sine. X equals. Now, one thing I will say before we type this in and do that is that 4 over 10 does reduce to 2/5, right? So do you want to go ahead and reduce it before you type it in? Or 2/5. It doesn't matter whether you type in inverse sine of 4 over 10 or inverse sine of 2 over 5. It will give you the same answer because they're both the same fraction, okay? So if you recognize that and want to reduce it so you type in smaller numbers, that's fine, but it won't matter, right? So, I mean, that's a thing. Inverse sine of 4 over 10 or inverse sine of 2/5. And it is... I got 23.6 degrees is what that will be. Okay, so there's that chunk there. And then we've got 3 left here to go through. It says draw the angle in standard position. All right, so we know that an angle always starts here and then it rotates around to this direction, right? So if I go up to this far, that would be 90 degrees, okay? And if I go all the way over to here, that's 180 degrees. So 160 would be like not quite all the way there. And that's what he's going to look like in standard position, okay? So in the second quadrant, draw an angle with the given measure in standard position. And there you go, okay? 14, we're going to still start over here again. And again, this is 90 degrees. Okay, this is going to be 180 degrees if I go all the way around here. 270 degrees is down at the bottom. That's 3/4 of the way around. So I want to go 280, which is going to be slightly past that. Oops, slightly past, like here. Okay, and that's going to be 280 degrees. I should label him 280. If I would go all the way around, that would be 360, so I don't want to do that. I want to just go a little bit past the 270 mark, and that is at 280, okay? All right, last one, 15. We're going to start here, and I'm just going to keep, 400 degrees is a lot, though, okay? 1 full circle all the way around. I'm just going to go that far. I know that that's 360 degrees, okay? So if I subtract, I'm just going to do it this way. If I subtract 360 degrees, I would have to go 40 degrees more, okay? We know 90 is up here. 40 degrees more is going to be a little less than half of that. So this is what 400 degrees looks like. It actually looks the same as what just 40 degrees would be if I'm just looking at like this part, this angle right here. But it actually is measuring 1 full circle around and then some. So it's kind of like a little spiral. So make sure that when you're drawing this, you're drawing your entire spiral so that I can see that you've gone around more than one time. Okay, so that's 15, and then we're going to stop there, and we will do the back side tomorrow. And if you have time remaining in class, go ahead and start some of these problems on the back side so that you can practice with them, because that's only going to help you study more or study better, I guess, for the test, okay? So get a start on those if you have time remaining, and we'll go through those answers tomorrow, okay?